Alrighty, welcome back. Today we're going to take a look at change of base with exponents to set ourselves up for some problem solving. So a couple of key things going on here on the screen. Got my examples, but our idea here is to figure out these questions without having to use a calculator. The only way we can do that is if we use some exponent laws to make it a little bit simpler. We can only use exponent laws if the bases are the same. Thus the title, Change of Base. So when we change the base to use our exponent laws, generally we want to write each term with base. So it'll be likely 2, 3, 5, 6, 7, or 10. Something that's a low number. Once we write the different base, we're going to use power over power. So what that looks like, I know that 2 to the exponent 3 equals 8. So I'm going to take out the 8 and I'm going to replace it with 2 to the exponent 3. Remembering there was already an exponent of 3 in the question. And I just changed the base but kept the value the same because 2 to the exponent 3 is 8. I do the same idea with 16. I know that 16 is the same as 2 to the exponent 4, or the answer to 2 to the exponent 4 is 16. So I'm going to, oops, that's not what I wanted to do. So I'm going to take out the 16, keep the question the same, take out the 16, and put 2 to the exponent 4. Remembering there was already an exponent of -3 there. So I've changed my question so that it has the same base, but I haven't changed the numeric value. After I change my base, I use the power rule because now I have one base with 2 exponents. So I can multiply my exponents together. 3 times 3 gives me 2 to the 9 times 4 times a -3 gives me 2 to the -12. Once I've done my power rule, usually we'll use a multiplication or division rule. So multiplying, because it's a multiplied question, I keep my base and I add my exponents together. 9 plus -12 is a -3. After I've done the change of base, the power rule, the multiplication division rule, then I'll deal with any negative exponents, meaning I remember to flip my base around and make my exponent positive, and now I can finally get an answer. So we're setting ourselves up here so we can solve some problems using exponents. So I'm going to give you a minute. It might be a good time to pause here to copy that example and those steps down. Once you've paused and gotten that copied down, we'll do a couple more examples together. So change a base. I want to get the same base. That means I want to lower everything. So the 9 is pretty easy. So 9, I know that 3 squared is 9. So I take out the 9 and I put 3 squared, and I remember there was an exponent of 9 there. Keep my divided by. 2,187 is a really, really, really big number. I want to change the base. I want to change the base so it's this. I'm probably going to change. Now I just have to figure out what exponent will give me 2,187. There is no button to push on your calculator. You have to play around and figure it out. So play around with your exponents. 3 to the exponent 8, 3 to the exponent 4, 3 to the exponent whatever, and figure out what it is. And I have discovered it is 3 to the exponent 7 is 2,187. So I take out the 2,187 and put 3 to the exponent 7, remembering to keep the exponent that was already there. Now I can use my power rule. So 2 times 9 is 18. And 7 times 3 is 21. And now I can use my division rule, keep my base, and subtract my exponent. It's negative 3. Finally, if there's a negative exponent, flip the base and make the exponent positive. And I finally get my answer, 1 over 27. So remember, if you have a really large number, to use the other number as a hint, because you want the same base. Other hints, if they all end in 5, you're probably going to use a base of 5. Hopefully we've done enough at this point that everybody knows that 125 comes from 5 to the exponent 3. Don't forget the 6 that was already there, and the multiplication sign that was already there. And hopefully everybody knows that 25 comes from 5 to the exponent 2. Don't forget the negative 5 that was already there. We might know that 625 comes from 5 to the exponent 4. If you've done quite a few of these, and don't forget the negative 2 that was already there. So power law time. 3 times 6 is 18. 2 times negative 5 is negative 10. Over 5 times negative 8. Then our multiplication and division rules. So the top is multiplying. I'm going to keep my base. And I'm going to add my exponents. Negative 10 plus 18 is 8. And now it's a dividing question. So I'm going to keep my base, subtract my exponents. 8 take away negative 8 will be 16. Remember, be careful with your signs. 8 take away negative 8 is 8 plus 8. And 5 to the exponent 16 is going to be a very, 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 very large number. Just looking to see if I wanted you to evaluate that. My calculator actually evaluated it. Some of your calculators will put it in scientific notation, and I believe we talked about that yesterday, how the little number means you move the decimal over however many times. All right, this might be another good spot to kind of pause and copy down an example. If you've paused, that's awesome. I've got one more to do. 81 and 27. You got to know your times tables. If you don't know your times tables, you're going to have trouble with this. So I know 81 and 27 are both multiples of 3. And I know I've done a few of these where I've learned that 3 to the exponent 4 is 81. So instead of that, instead of 81, I'm going to put 3 to the exponent 4, and then I have this crazy fraction exponent that was there. And hopefully you've done enough of these to remember that 3 to the exponent 3 is 27. So I take out 27 and I put in 3 to the 3, and remember that fraction that was already there. So I'm going to do my power rule. That means I've got 4 times 5 over 2. Be careful with fractions. When you're multiplying and there's no bottom number, you can add a bottom number of 1. Make sure if you're adding a bottom number that it is 1. And then you can multiply them. So I've got 3 times 1 over 3. Add a bottom number of 1. So keep my base. 4 times 5 is 20. And 1 times 2 is 2. Keep my base. 3 times 1 is 3. And 1 times 3 is 3. And I can simplify. 20 divided by 2 is 10. And 3 divided by 3 is 1. Now it's a multiplying question with some nice exponents I can add together. 3 to the exponent 11. Let's see if our calculators will handle that. 3 exponent 11 is 177,147. So if we need to go back and replay the video to get the examples down, otherwise there's another handout. You're going to try question number 1 on that handout. Make sure you get the examples copied down in your notes first.